guys, this is Mrs. Cameron here, and we are looking on page 11 of our yellow packet. I think we got this. This is going to be the time. This will be our last time you have to take this test. I'm going to be done with that. All right, number 13 on page 11. Write an equation of a parabola that has a vertex of 3, 4, and passes through the points 1, -12, and 4, 0. Write your final equation in standard form. So our keyword parabola here is telling us that our graph is going to look like a U or an N. Oh, what's going on with my pen? Let's see. Oh, sorry. Let me clear that out. Parabola is telling us that our graph is going to look like a U or an N. So that is a quadratic function. And they've given us the information to write a quadratic function in vertex form. So when you look at the reference sheet for quadratic functions, this is the second formula. So that formula says f of x equals a times x minus h squared plus k. And then what you have to know about this is that this is our vertex form where hk is the vertex. So I'm going to start with this, and I'm going to call my f of x y. So I'll rewrite that under here. Y equals a times x minus h squared plus k. And now I'm going to erase my h. And write my x number for my vertex. And I'm going to erase the k. And write my y number from the vertex. And both of those numbers in my ordered pair for my vertex are positive, so I didn't have to change any of the signs. Now I can take my points over here and replace them for my x and y to find out what my a has to be. So I will choose the second point here because it has a 0 and there's no negative number, so I feel like that'll be a little easier for me. So I'm going to erase the x, and I'm going to write in my x value from my ordered pair. And now I'll erase the y and write in my y value from my ordered pair. Now I can start simplifying. 0 equals a times 4 minus 3 is 1. 1 squared is 1, so that's just a, plus 4. And now I know how to get my a by itself. I can subtract 4 on both sides of the equal sign. So a equals -4. And now I can write my equation in vertex form. So my next step is to take what I know for A and rewrite this formula using this A, and it'll be in vertex form, but the question tells me to write it in standard form. So once I get it in vertex form, I have to change the formatting to put it into standard form. So here's how we do that. F of x equals a times x minus h squared plus k. And I'll change my color. And I can erase my a and put in -4. And I can erase h, and put back in the 3. And then I can erase my k and put in that 4 from the vertex, just like I did over there. And now I can turn this to standard form. And standard form, when you're looking at the reference sheet, is the first formula under forms of quadratic functions. That's the f of x equals ax squared plus bx plus c. So I'll write that down at the bottom. Standard form. Is f of x equals ax squared plus bx plus c. So I got to make this look like this. In order to do that, the first thing I need to do is multiply my x minus 3 squared. So I'm going to use the area model to multiply that. You guys taught me that, and that has been my go-to, so thank you. So I make my box for my area model, and I've got x minus 3, so x and -3, and that's squared, so it's the same thing over here, x and -3, a binomial times a binomial. X times x, new color. X times x will be x squared, x times -3, -3. X times -3 again, -3. X and -3 times -3, negative times a negative makes a positive. 3 times 3 is 9. So I can bring this in over here. F of x equals, -4 times, now instead of writing this x minus 3 squared, I'm going to bring this information over here over. And I'll simplify it underneath actually first. X squared, nothing can go with that. That's the only x squared. And then -3 minus another 3x, that's -6x. No other x's can go with these two. And then this lonely 9 off on the end. So I'm going to write all of that in. X squared minus 6x plus 9, close parentheses, because that -4 was on the outside of all of that. And then a plus 4, I'm just going to bring it down, plus 4. And since I'm done with that, I'll go ahead and erase this so it's not so messy. And now I can do what with that -4 outside of the parentheses? You're right, it's time to distribute or multiply, however you want to call it. So -4 times x squared. So f of x equals negative 4 times x squared. Negative 4x squared. And now negative 4 times negative 6x. Negative times negative turns positive. 4 times 6, 24. And carry the x over with that. And then negative 4 times negative 9, and negative times a positive is a negative. And 4 times 9 is 36. And then bring down my plus 4 from the ends. And we are almost in standard form. One last step is to simplify our like terms, combine our like terms here. Negative 36 plus 4, negative and a positive, combine those, it'll be subtracting because the signs are opposite, and the number will stay negative because the negative number was bigger, right? So bring that down. Everything else is just coming down. F of x equals negative 4x squared plus 24x. And we said negative 36 plus 4 is negative 32. And now this looks just like the standard form. Check the answer key. And we are done with number 13. For practice on this, in addition to anything else that I've had you look at for quadratic formulas, we've got lesson Y, G, V on IXL. So I recommend this lesson for practice on IXL. Make sure that you're logged in to your account through our district's Clever information before starting the lesson so that I can see the questions you've answered so I can give you a weekly grade. And then continuing on the page to number 14, your school wants to maximize their profit, P, from the sales of tickets, T, so profit, and tickets, T, to the homecoming football game. They determined the function that models the profit they can earn in hundreds of dollars in terms of price per ticket in dollars. The function is given below. What price per ticket maximizes your school's profit? So we are right away, when I read this question and look at the function here, we can see that that's a quadratic function in standard form, just like number 13, we had to write it like that. And the keyword maximizes, that's telling me that this quadratic function, right, it's going to be like an n with a maximum at the top. And what price per ticket? Price per ticket. And if this is the profit, blue is the ticket sales, right? So we have to find out what's T at the vertex. And in order to do that, this is actually on our quadratic function. This is where our axis of symmetry is. And we need our T for P of T, right? Because on this is what our X, Y values would look like for our function. So to find that, we're going to use that formula. I said that that if you want to use it, if you want to get these questions right, you have to memorize your formula for axis of symmetry. They do not give you this formula on your reference sheet. So that is where x equals b over a times negative 2. That's the formula I said you have to memorize. And then for this word problem, our x is actually t, our price per ticket. So t equals x, b over a times negative 2. And while we're in standard form, and I've already written it from the question above, I can find my numbers really quickly here. So this equals, for b, we have 210 over a times negative 2. And our a, we have negative 30. And now we just continue through. On the top, we keep our 210. And negative 30 times negative 2. A negative times a negative is going to turn to a positive. And 30 times 2 is 60. And now every fraction is a what kind of question? Every fraction is a division question. So you can just divide that on your calculator and you're going to get 3.5. And then the question is, what price per ticket maximizes your school's profit? So we just need to take our answer here, our 3.5, and turn it to look like money. So I'm going to put a dollar sign, and we got $3.05, and that almost looks like money, right? In order for it to be a money answer, we got to have, if there's something behind the decimal, we got to have 2 numbers behind the decimal, and always behind a decimal, the invisible number, if you need to fill in a number, if there's nothing, that invisible number is 0. And this is our final answer for this question. And now to practice this on IXL, I'm gonna recommend, again, I think I've already said this one, and it's, oh, no, maybe I didn't. IXL lesson, YJZ. So if you've already done this on IXL, because I had you do it earlier, then maybe just try one more question, or if you feel like you need to get your SMART score up to, if you're at an 80, get to a 90, get to a 100, whatever you think you need to do to feel confident on this standard. I think looking at this question is pretty fair. It was definitely a little less work than the question above. And like I said, make sure you memorize your formula for axis of symmetry. Because that also gives you your x value for your vertex. So that'll be multiple questions that memorizing this formula will help you with. All right, I think we got that. And there's 2 more questions on this page, so let's continue to number 15. Write an equation of a line that goes through the points -2, 4, and is perpendicular to the line that goes, the line y equals 2/9 x minus 5. So our equation here of this line, my keyword perpendicular is telling me something about the slope. And I can see the slope of this line because this formula, this equation, is in slope-intercept form. And I can write an equation in point-slope form. So this one here is in y equals mx plus b format, where m is the slope. And I can write an equation in point slope format. And if you look on your reference sheet, they do give you this formula on your exam. It is y minus y. Actually, I'm going to move it over a little bit. Sorry. And our point slope given to you on the reference sheet is y minus y1 equals m times x minus x1. And that's it. So, looking at this, perpendicular slopes, when you see this, you're probably going to be tested on both perpendicular and parallel slopes. Parallel slopes are equivalent. Perpendicular slopes are two things. They are, one thing, they are upside down. So if it's giving you a whole number, you would turn it to a fraction and then flip it upside down. And perpendicular slopes are also opposite signs. So if this is positive, our slope for our line will be negative. If this were negative, then our slope would be positive. So upside down and opposite. So to make it upside down, instead of 2/9, it's going to be 9/2. And instead of being positive, ours is going to be opposite, so it's going to be negative 9/2. So for our line, our slope is right here. And for our line, our point is right here. That's our x, y. So now I can come back to the formula and just plug these things in, and technically we're done with the question. So I've got I'll write it again. Y minus y1 equals m times x minus x1. And now I'm going to come in and erase. I'll erase my slope first. And our slope, we said, is negative 9/2. And then our x value here is negative 2. So minus negative 2 is going to turn into plus 2. And now I'm going to erase my y1 and put 4. And now technically right here we are done with this question, but just in case, I'll finish. I'll do an extra step here for you because they may ask you to put this equation in slope-intercept form like the original equation was. So to do that, I can pretty quickly distribute my negative 9/2, and I can move my minus 4 from this side over to the other side. So I'm going to write y equals negative 9 over 2x, and then distribute negative 9 over 2 times positive 2, negative 9 over 2 times positive 2. I'm going to turn that to a fraction because I have a 2 across from a 2. They're going to cancel each other out to be 1, so this really just equals negative 9. Negative 9, and I have to add this 4 to this side, plus 4, and negative 9 plus 4 signs are opposite, so I would subtract them. 9 minus 4 is 5, and my negative number is bigger, so it'll be negative 5. And this is the same equation, the same line, just in slope-intercept format. And to practice this on IXL, I would recommend lesson 5SH. And I believe this one is going to give you practice for those parallel and perpendicular slopes. And if you look ahead at the packet on page 18, number 42, it's asking for a parallel slope. So this question number 15 goes right along with question number 42. So if you want to skip ahead and try question number 42, before you get to it on the video, now is a good time to do that since you've looked at it. Perpendicular, parallel slope kind of goes with that. And last question on the page, number 16 on page 11 says, describe the end behavior of the equation below, then describe what y is doing over the whole function. So when we look at this, number 16, I can see right away that we have an exponential function because we have a number to the power of x. And if you look on your reference sheet under forms of exponential functions, you have the first equation, f of x equals a b to the power of x, where a is your y-intercept, and b is telling you if b is less than 1, your function is decreasing, and if b is greater than 1, your function is increasing. And that's all that it tells you actually on the reference sheet is f of x equals a b to the power of x. You've got to memorize that a is the y-intercept and b is telling you what the function is doing. So for me, right here, I would make a little table for these values to kind of see, okay, what's going on here for my x and my y values. So when x is 0, 7/9 to the power of 0, anything to the power of 0 becomes what? Anything to the power of 0 becomes what? If you don't have that memorized, plug that in on your calculator and make sure that you remember to look that up. Anything to the power of 0 is 1. So when x is 0 here, all of this turns to a big old 1. And so 1 times negative 2/3, our y would be negative 2/3. So on a graph, we're looking at a point down here. And then if we plug in a 1 for our x, when x is 1, if this x was a 1, then this 7/9 just stays 7/9, and we're multiplying this as is. So 2 times negative 7 would be negative 14 over 3 times 9, 27. And can't simplify that, but that would be a little bit less negative. So we're coming up like this, a little bit greater. And negative 14 over 27, and clear that out. And when x is 2, so we would square this. So I would put this in on the calculator. When x is 2, calculator mode, 7 divided by 9, and square it. Now don't clear your calculator, and press times, and our negative 2/3 is equal to negative 0.666666667. So multiply that, and you're going to get about negative 0.6. And we're coming up like this. And you can just look and see that that our function is end behavior, right? If we were to graph this, we're going to get something like this. Too bad we're not allowed to use a graphing calculator like we are on SAT and ACT, but without a graphing calculator, you got to kind of plug in to see what's going on. Or at least I do. I don't know, maybe you know a faster way to do this, but for me, this is what I do. So the end behavior while x is heading towards negative infinity, right? So as we go this way on our graph, as x is heading towards negative infinity, y is heading towards negative infinity. And as x is headed towards positive infinity, our y is doing what? So as we go this way, our y is heading towards 0. So the bigger number that we would put in for this x, the closer we're going to get to 0 over here. So that's our end behavior. That was the first part of the question. And the second part of the question says, what is y doing over the whole function? And our y is always negative. Negative, negative, negative. So we'll write that in. That's the second part of the answer. Y is always negative. So we have answered both pieces of the question for this exponential function. And to get in some similar practice to this on IXL, I'm going to recommend lesson BYF. And I hope that this is helping you to feel confident and ready for your algebra EOC for the Florida Best Standards. Make good math choices, and I'll see you later.